How's everyone doing today? Good? Excellent. Thank you so much for finding Caesars Forum. It's kind of rough finding a way over here. My name is Dave Ward. I am the General Manager for Application Networking, and I'm joined by Mike Wittig, who is the Chief Information Security Officer at Block. And we're going to be talking today about what the network can do for your application. It's an exciting, jam-packed session, and we're going to start by defining what application networking is, because I say it, and it's not a well-understood term. It's sort of like IAS or PAS used to be, any of those. And then I get to share a little bit about what my teams have been building this year and how they can help you build more resilient, more available applications. And finally, Mike's going to take us home and talk about a little bit about how his teams are leveraging application networking, in particular VPC Lattice, which is our newest application networking service. So let's get started. What is application networking? Well, at Amazon, we always start and work backwards from our customers. And there's two key personas that we think about. The first is networking and security engineers. These folks are really focused on compliance standards, making sure that you have the top security you possibly can, as well as just making sure you can connect from point A to point B. And then you have the application developers. These folks really are focused on building business applications and business logic for your end users. Well, application networking is really about building managed services that really are the glue between these two different groups. When you break it down, there's a common core set of functionality used by both of these groups. It's about connecting, securing, understanding what's happening within your application, as well as being able to troubleshoot issues as they emerge. And that's the reason why we built our application management services. This includes elastic load balancing, private link, API gateway, and VPC Lattice. The common link between these is that they're a managed service. So our goal with them is to take away the undifferentiated heavy lifting that both of these two groups require. But we think about it slightly differently at AWS. Every week, I get the opportunity to sit down with 1,500 customers, my internal customers. And these teams are often telling us ways that we can elevate their availability and security by putting it in our centralized layer. And so that's what we plan to do with application networking. It's really about increasing availability and security, not just for ELB, but also for all of your applications. And that's the reason why our priorities this year have really been focusing around raising security, availability, and then in particular this year, we've been focusing on expanding selection in our partners and how they can help you get additional functionality. Let's dig into the first service, elastic load balancing. Elastic load balancing, for those not familiar, have four key products involved. The first is application load balancer, ALB. This is our request-based load balancer that operates at layer 7. We have network load balancer. It's a connection-based load balancer that operates at layer 4. We have gateway load balancer, which is a way of transparently inspecting traffic and routing and load balancing across networking appliances. So it operates at layer 3 and layer 4. And finally, classic load balancer, which was our original load balancing product for both layer 4 and layer 7, and we leave it as an option for our customers. Across all these products in ELB, we have one key top priority, and that has to be security, because a number of you all run a large portion of the internet through application networking and through ELB in particular. This year, we've heard a number of you require things in your compliance departments in order to meet elevating standards. Additionally, there's also things that we've heard from you all really focused around how we can do more within the load balancing layer. That's the reason why we released a number of features this year that I'm excited to tell you about. The first is that we heard from you all that TLS 1.3 was becoming a requirement by your compliance departments. TLS 1.3 allows you to build low latency applications using one round-trip TLS handshakes. Using TLS 1.3 for ELB, which is available for both NLB and ALB, you can choose one of 7 predefined TLS policies so that you can meet your different compliance standards. Additionally, you can choose to avoid using certain cipher suites in order to achieve perfect forward secrecy. Next up, we heard from you all that you wanted to meet TLS standards for the US government. This means that you have end-to-end encryption from the client to the load balancer and the load balancer to the target, but are meeting FIPS compliance. That's the reason why we released FIPS for ALB and NLB. And FIPS for ALB and NLB was implemented using AWS libcrypto. This is effectively a NIST certified module that's maintained by AWS cryptography. And it adds on top of what we use actually for TLS 1.3 as well, S2N, which is our fast, security-focused, formally verified TLS implementation that we've built over the years. Between these two, the other requirement we heard is that we wanted to ensure that we had compliance standards across all of your different accounts within your organization. And that's why we've introduced additional IAM condition keys, which allows you to specify TLS policies as well as IP-based access controls across every account within your organization. By far and away, the most requested feature, perhaps one of the most requested in AWS itself, has been the ability to authenticate clients using TLS or mutual TLS. This allows you to verify parties at both ends of the connection and by validating it with the appropriate private key. This is often used for Internet of Things applications as well as mobile applications that need low computational costs and lightweight mechanisms for security. That is the reason why I'm extremely excited to announce mutual TLS for ALB. Using mutual TLS for ALB, you have two different options. The first is that you can use pass-through mode. Pass-through mode effectively allows you to add the entire certificate chain to your HTTP headers, and then that will actually be passed to your end target, where you can perform the validation. The other option is what we call the full verification mode. In this mode, you actually verify on the load balancer itself. You have two different options. One, you can use third-party certificate authorities, or you can use ACM private certificate authorities as your trust store. Additionally, we have the mechanism for certificate revocation lists if you ever need to remove any of the certificates. The other area where we heard a lot of requests was around security groups for NLB. It used to be that many of you use security groups on the targets themselves in order to reject traffic. The challenge with this is it meant that traffic was coming all the way from the internet and hitting your targets before it was rejected. Instead, what you wanted was security groups on NLB itself so that you could reject traffic much earlier in the actual flow. And that's the reason why we released it earlier this year. Using security groups for NLB, you have the ability to set both IPv4 and v6, both ingress and egress rules, as well as you can use security group referencing. This is now becoming a best practice across NLB and definitely something I would recommend checking out if you haven't already. Security absolutely is a top priority, but one of the other areas that we hear from you all often is that availability also has to be a top priority for us. And that's the reason why we are absolutely focused on it. Now, ELB has been phenomenal at actually detecting and staying very highly available for clean failures. However, we saw an opportunity to improve how we can behave during gray failures. Gray failures, if you're not familiar, are really where health checks, which is the primary mechanism to know if targets or load balancing infrastructure is healthy, the health checks themselves don't fail even though there may be an issue. As an example, there could be an application issue on your target and it's not detecting it because it's not a deep enough health check. Well, the two primary scenarios where there's gray failures, the first is when there's an availability zone failure. That means maybe there's a physical networking failure or perhaps a power failure where some of the dependencies in your tree are not actually fully failed, but your health checks continue to pass. The other is where there's a target failure. And this is where you may have a scenario where your application has failed, perhaps you have a bad deployment, but your targets are continuing to pass that health check and hence creating 5xx errors or some other sorts of errors. So we took a phased approach at seeing how we could eradicate all of these gray failures. First, we really focused on how can we help you to achieve the best and most ideal architecture to recover for failures. Second, we provided manual tools to help you recover from issues faster. These are the same sorts of tools we use internal to AWS to recover from issues if there's an application issue. And finally, and my kids like to call this the auto-magical mode, is where you automatically detect and mitigate issues whenever they occur. Let's dive into it. At AWS, we really try to work backwards. And so it's worth understanding the architecture that we're trying to work backwards from. There's so many different architectures out there, so we focused on one of them. And this is the way we build internal to AWS. Many of you all may be architected this way today, which it means that you have cross-AZ communication both from the client to the load balancer and the load balancer to the target. This can be useful in some modes, but during gray failures, it makes it really challenging. Additionally, if you want to recover from failures faster, being able to remove the entire availability zone at a time allows you to mitigate the issue, even if you don't know the root cause, basically alleviating it for your customers. That's the reason why, as we're architecting for this ideal architecture, we really want to minimize the dependencies between availability zones. Let's work backwards from the top of the architecture all the way down. The first is health checks. So health checks really come in two different flavors. First for the availability zone, and then for the targets. For the availability zone, what we saw was, by default, you basically have to fail 100% of the targets before we fail away from an availability zone. This obviously during partial failure scenarios is not ideal. Additionally, from a target perspective, you really want to be in a place where you could remove the targets very rapidly if they're failing, but be very slow to put it back in so that they don't flap. So we introduced two different configurations. The first is really around what's the minimum healthy targets before you fail away from an availability zone. And the second is really how many health checks need to be successful or fail before we either add or remove that capacity. Next up, we really tried to focus on how do we keep traffic local. And so this first one is really about keeping traffic local between client and the load balancer. So for NLB, we introduced something called zonal DNS affinity. This basically removes the cross-AZ traffic and keeps it local, with one exception. If that load balancer infrastructure in that AZ is unhealthy, it will try to actually connect to the other availability zones. So it's an incredibly useful thing. It also can help you reduce your cross-AZ data transfer charges too. So definitely something quite useful. Next up, we really wanted to restrict traffic from the load balancer to the targets themselves. So we introduced a new setting called Disable Cross-Zone Load Balancing. This is available for both NLB and ALB. And effectively what this will do is only from that load balancer, it will only distribute traffic to targets in that availability zone. There is a caveat, I would say, which is you have to make sure you have sufficient capacity in that availability zone to use this. Because if you don't, and one of your availability zones fails, you might not have sufficient capacity to keep up with your application, in which case you're going to introduce errors when you're really just trying to get to recovery. So please make sure you have enough capacity in each of your AZs to withstand an AZ failure. All right, finally, we looked at the connection layer. We said, what could we do to improve connections? There's two different areas we saw. The first is really around UDP. Just based on the way the protocol works, you could end up in a scenario where you black hole traffic if targets go away or become unhealthy. So we introduced something that allowed a maximum timeout associated with a connection for UDP. And second of all, we really wanted to prevent against thundering herd scenarios. This is where when either a target or availability zone becomes unhealthy, it causes all of those connections to reset and go to either a different AZ or targets. And so that can actually overwhelm your application as well, whereas normally in steady state, it would be perfectly fine. So connection termination for unhealthy targets effectively allows you to do that naturally and only disconnect when the client would normally just disconnect, staggering those connections as they fail over. Great. So now we have a bit of an ideal architecture. The next area is we're beginning on a journey to actually update Trusted Advisor to have a bunch of this information in there for you. We're starting with adding the ability to detect if you're in multiple AZs or not. As you can tell, having the NLB actually maintain that DNS record allows us to do a lot on your behalf, and I'd encourage you to make sure you don't have siloed NLBs, and so that's this first check. Great. So we have the ideal architecture. Hopefully we begin on that journey to tell you about how opportunities to make your availability better. Next up is providing you the tools so that you can fail away. So internal to Amazon, when we have an issue, the very first question we ask is it located simply to an availability zone? If it is, we can simply remove that availability zone and get back to recovery. So we always focus on mitigating first. Zonal shift effectively allows you to do that very thing. So if you have deployments that are going a zone at a time, instead of just simply rolling back, you can wait away. And so if your clients have the right TTL, you get to recovery within minutes as opposed to potentially a much longer period of time. So now this is in your hands as well. But again, going back to my kids, they really want to be in auto magical land. So yes, you can remove the IP address, you wait it away, but they want to be in the auto magical land. There are two different places where we can automatically take action for you. First is at the load balancing layer, and the second is for your targets. On the load balancing layer itself, for years, ALB has had the capability to determine if there's anomalies associated with the load balancing infrastructure. With NLB, though, there's a slightly tricky thing, which is we do health checks specifically looking at each and every target, and it's only when 100% of those targets fail that we wait away. And so the assumption is that it's going to have that consistent failure mode across all the targets, and that will detect when the actual load balancer infrastructure is bad. It's not a great example of, it doesn't work as well as we would want it to for grave failures, which is why we've recently, as in the last week, updated our infrastructure to do much deeper health checking against the entire infrastructure. So the way it works is our target health checking subsystem will now do a deep inspection of the actual load balancing infrastructure. And if any parts of those load balancing infrastructure fail, it will actually return to that target health checking subsystem and say, guess what? That availability zone is impaired. The infrastructure there is impaired. And it will automatically wait away. So during grave failures, we're in a scenario where we automatically recover on your behalf. And so as an example, like if there's an AZ failure or something else there, we're going to get to recovery much, much faster. Now let's focus on the targets, because we have you covered on the load balancing side. With targets, getting health checks right is hard. We've heard this often from our internal developers, and it's amazing the number of issues where we reviewed them, where either developers inside Amazon create health checks that are too light, they simply ping the target itself and say, yes, I can connect to it, or they create these really deep health checks, but then on a deployment failure, they remove the entire set of infrastructure. That's not good either. So we asked the question, what could we do at the load balancing layer? And it turns out we have a lot of information about your application, especially at the layer 7 layer. So we said, great, we should be able to figure out the ideal weighting for each of your targets. And the first iteration of this is really focused on health. So we introduced something called automatic target weights. This was just released this week. So effectively, if you have an instance that's failed, what will happen is we'll iteratively reduce the amount of traffic going to that target and get you to a place where either that target begins to respond because it's no longer overwhelmed, or it will be removed from use with a very small trickle of traffic going to it so we know when it becomes healthy again. This gets you to a place where you're recovering very rapidly. Even, let's go back to that example of deployments, where you're developing and deploying to a single availability zone at a time, you can recover automatically as you're doing those deployments. Now, there is two different modes for this. The first is where we actually emit a CloudWatch metric. The second is where it will reduce this. So you have the ability to have those CloudWatch metrics so you could do an automatic rollback as well. This becomes a really powerful tool in your arsenal to making sure that you're elevating your availability. Now, I would encourage you to check it out today. This is one of those things we've run in shadow mode for a number of applications for weeks and perhaps about a month now. And the amount of availability we would have improved in those applications was significant. So please check this out. It's definitely one of those learnings we've had internally. Just as a quick recap on ELB, it's been an incredibly full year. We've had a lot on both the security, like MTLS, as well as on the availability side with things like automatic target weights. One of the things that I didn't have a chance to talk about is our integration with EKS, with our EKS controller. There's a substantial amount of innovation that's happened there over the past year. For example, one of the most recent things allows you to use the same load balancer across the entire cluster, which gives you an opportunity to save a lot of money. So I'd encourage you to check that out as well. On the network load balancer side, this has also been a very jam-packed year with everything from security groups on NLB to a lot of the availability improvements like zonal DNS affinity. one of the things that I didn't have a chance to talk about was improvements on target registration and deregistration delays. So one of the pieces of feedback that we've heard from you all has been that it sometimes takes longer than you would like in order to register or deregister. So we've been working on that a lot and has substantially reduced the amount of latency associated with that. So please check that out. Okay, let's move on to our next service, API Gateway. So at Amazon, we think about the world in terms of building blocks. And with building blocks, we tend to start at the most foundational layer, giving you the ability to have the right knobs and controls, and then work your way up the stack. In particular, we heard from you all that you wanted control planes that often work with Lambda. So in 2015, we introduced API Gateway, which provides the ability to create, publish, maintain, monitor, and secure APIs at any scale. The way that it works is that we publish an endpoint onto the internet that effectively has predefined APIs that you define. And when that API is called, it effectively kicks off either synchronous or asynchronous workflows. It also has the capability to do things like authentication and authorization, request-reply transformations and validation, as well as the ability to do API rate limiting. API Gateway is one of those services that we actually see as foundational internally. It's used across 80 AWS services, as well as many of the use cases we hear from you all range from things like operating elevators to in the midst of heart transplant logistics. So this service itself, we just absolutely have to get it right. The growth on API Gateway has actually been amazing, and it's outpaced our very internally aggressive milestones. And so it's a super exciting service, and it's one of those things where it's also not too surprising because this is one of those areas where as you're building control planes, it really simplifies that customer experience. But one of the things when you're building a service like this is that often we spend a lot of time internally focused doing things to keep it simple. So this is very similar to other services you may see like S3, where they spend a lot of time behind the scenes doing a lot of complex engineering to get you a very simple experience. And so with API Gateway, some of the examples of projects we do to really help you elevate that availability are similar to what you would see on ELB, but they're actually abstracted away. Things like focusing on cellular architecture and making sure that we can cleave away entire portions of that architecture automatically, really focusing on mean time to recovery, especially with gray failures, as well as the ability to add additional capacity very rapidly and start as, if there's a power outage, start from scratch and bring up the entire infrastructure. And so there's a lot of this complexity we do on your behalf, and it's abstracted away, which is awesome. But it's very similar to ELB in terms of our availability roadmap and whatnot. Another area where we spend a lot of time is on the developer experience. And with API Gateway in particular, one of the areas that we've heard is that while many of you use infrastructure as code and use our APIs and whatnot, especially when you're creating new API gateways or experimenting, you'll leverage the AWS Management Console. And so feedback from you all has been that the old console wasn't as intuitive, and there was a lot of accessibility potential improvements that we could make. So over the last year, we've been on a journey to really improve that. We've changed over 115 different views, 549 different accessibility improvements, including dark mode. And so a substantial amount of improvement. The feedback so far from you all, and thank you for providing that feedback, has been that this is definitely a stair-step improvement in the actual user experience. And so I'd encourage you to check it out if you haven't already. The last area I'll talk about is really about our work around partners. And so this is an area where we really want a group that provides a lot of selection and capabilities to you all. A great example of this is README. README provides developer portals, and so you can do things like create code samples and documentation, API references, and do things like, as you're in documentation, actually try out the code real time and see real-time logging to understand what's going on in your application. So if you have use cases like a developer portal, I'd encourage you to check out README or other partner options, and you'll continue to see us work with our partners to really provide that diverse selection of capabilities. API Gateway in general is just an area where, as the owner of application networking, I am keenly focused and we're investing a lot, and I'm excited to see all the things we're going to release next year as well. So stay tuned in 2024. There's not just going to be things that we do behind the scenes, but also additional things that you'll see externally too. Private Link is our next service. How many of you use Private Link? Yeah, so a bunch of you all. Private Link effectively makes it very easy to connect to SaaS applications or AWS services that are located in other AWS accounts or VPCs. This is effectively becoming the default way to connect to both AWS services and SaaS type offerings. Customers tell us that they love Private Link because of a bunch of different reasons. The first is that connections are client initiated. This means that if you're accessing a third-party provider, you have access to their application, but they can't actually reach back inside your VPC. Second of all, it has really rich semantics around security. And so you can do things like, if you're accessing an AWS service, be able to specify the VPC as well as the APIs that you want an IAM user to have access to. Next, it really provides the ability to access from on-prem to different AWS accounts or VPCs, so you can access those different services and whatnot. And that also works vice versa. And finally, it provides a substantial amount of data, including contributor insights, which can actually provide you the ability to have top talker information, as well as a host of other pieces of information. The primary use cases tend to be twofold at this point. The first is really around services, and the second is really around networking appliances. When it comes to services, the primary ones tend to be first AWS services. There's over 155 different AWS services already integrated in with Private Link. So effectively, pretty much any AWS service you want to access over Private Link, you have access to. Second of all, if you have your own developed internal application, perhaps you want to host it in a centralized VPC, you have access to it through Private Link. And finally, third-party providers. This really comes down to us making sure you have a rich selection to be able to access those types of applications that you already do without having to go over the internet. This is just a quick sampling of some of those different partners out there. We have over 200 different partners type offerings, so there's a substantial amount. If we don't have those offerings available to you today, I would encourage you either to reach out to your AWS account rep or perhaps to that third-party provider and really encourage them to get Private Link because, again, this is emerging as that default new normal. Again, there were two primary use cases. The second one is built around networking appliances. Networking appliances are often actually shown through Gateway Load Balancer. Gateway Load Balancer provides the ability to transparently inspect traffic going between source and destination. Effectively, what it will do is, first you create a Gateway Load Balancer endpoint. This is effectively like an IP address in your VPC. You put it in your route table, and it will allow you to transparently route to a Gateway Load Balancer in a different VPC or account. That Gateway Load Balancer will then load balance across networking appliances, allowing you to do things like firewall as a service. Those Gateway Load Balancers, or those networking appliances, will then have a choice on whether or not to drop traffic or actually send it onto the destination. At that point, it's assuming and routing onto the destination, and it will return through that same path. Previously, the way that this worked is that often you would create EC2 instances, and using that route table directly route traffic through it. There's a couple of things that make this a much better architecture. First is that from a reliability standpoint, if there's a failure in any of those instances, the load balancer now can actually route that to a different networking appliance behind the scenes. Two, from a scalability perspective, the load balancer appliances can scale out. Next, it actually transparently provides, it doesn't change the IP addresses, so your destination will actually think it came directly from your source. And lastly, you can put networking appliances in different VPCs or different accounts. And so there's a lot of improvements with this net new architecture. There are three primary use cases. The first is what I call the do-it-yourself method. So using the AWS Marketplace, you can use AMIs that are pre-built by folks like Palo Alto or Fortinet, and you can run instances with that software pre-installed behind your Gateway Load Balancer. The second option is if you want to build your own appliances. And this is often useful if you want to transparently inspect all the traffic or log it out somewhere. Additionally, you may want to be in a situation where you drop traffic because you want to do like a Chaos Monkey type operation, or perhaps you have your own firewall as a service. The final thing is really around that third-party managed partners. And so we have a wide selection of these that range multiple different use cases. Again, Palo Alto and Fortinet are a great example as firewall as a service. The second up is really around analytics, and so we have folks like NetScout. There are network management partners such as Terraform, and finally there are service integrators, system integrators like Accenture that work deeply with Gateway Load Balancer. When we originally built Gateway Load Balancer, our focus was really on internet traffic as well as traffic between service to services. However, we heard from you all that you wanted the ability to inspect traffic from on-premises, which is the reason why we've integrated with Virtual Gateway, or VGW. There are two primary ways that you integrate here. First is if you send traffic over the internet using IPsec. The second is if you leverage Direct Connect. This is the more secure of the two options, but now you have that ability to inspect that traffic as well. Both Private Link, Gateway Load Balancer, this entire area is very exciting, and one of those areas that allows you to leverage third parties especially, and I'd encourage you to check out that selection. Okay. Last up, last year, we were on a mission, and all of these areas that we've talked about, even though it pains my heart to say, there's a lot of networking muck in it all. And so we are really interested in how we up-level to make it very simple for application developers to just build their applications. And also system and security engineers and networking engineers to help them more easily enforce defense in multiple layers as opposed to what they're currently working with, and simplified network designs and diagrams. So that's the reason why we introduced VPC Lattice. VPC Lattice is a managed application networking service that allows you to connect, secure, and monitor your applications without having to understand the underlying networking concepts. It effectively combines ALB, Transit Gateway, and Private Link together. It provides you the ability to define the guardrails and define policies so you can govern your network. It also provides you traffic management tools like the ability to do application layer load balancing and weighted target groups as well as blue-green deployments. And lastly, it provides you many of the tools you need to maintain and troubleshoot your applications. The things that really distinguish VPC Lattice really come down to the fact that you can leverage any compute platform that you want. So as an example, if you want to use EKS and ECS, you have that capability. If you want to use auto-scaling, you can use that as well. And you interact with it in that native kind of construct. And so again, this is targeted towards those application developers that don't want to understand that networking muck. The other really cool thing about it is that you can actually have that private link functionality of being able to access different accounts and VPCs using VPC Lattice. And so it simplifies greatly the need to link together multiple things to piece together an entire application. It also obeys existing rules and settings that you have out there, like security groups. Perhaps the coolest thing, though, is the way that it improves the security. So many people are migrating to it because it provides zero trust. And not just zero trust, a lot of people often think about the world in terms of really high, like walled gardens, where they create their VPC, but they trust everything within that VPC. With VPC Lattice, we go the next step further. We really focus at the service itself. And so what you can do is using a link local IP address, route traffic privately from that source to the actual end destination service. And so you can create that private connectivity between the two. And then you can add additional layers on top of that, like IAM policies. And with IAM policies, you can treat your services as though it's a resource within the IAM policy and really build these very rich policies out of VPC Lattice. So you're getting that service-to-service connectivity, but far more secure than anything you can build today. And finally, and this is one of the things that I spend a lot of time with many customers talking about, is you can migrate at your own pace. And so many folks, when they first look at this, they say, oh, I have to move everything all at once to VPC Lattice. But that's not the case. You can start with an individual service. You can actually integrate existing services using NLB or ALB on ECS or elsewhere that's built differently, but allow that connectivity between the two. And so you can migrate at your own pace, but as you add more, you get exponentially more value. Earlier this year, so that's what we launched with Preview last year at reInvent. Earlier this year in March, we released in GA, and when we released there, we released support for IPv6 as well. This helps not only with cost, again, reducing the number of IPs that you have to use across your business, but also allows you to communicate IPv6, which is also a benefit, especially in the containers world. We launched custom domain names. So the way that VPC Lattice works is that we use DNS addresses that point to that link local IP address to make it very easy for any client that you're working in or any service to connect to wherever it needs to go, because DNS is a well-known concept. And so with custom domain names, you can create that human-readable version of that FQDN that you want to route things to. And finally, we expanded to more regions. So rather than hearing simply from me on all the amazing things that I love about VPC Lattice, I'd love to turn it over to Mike Wittig. Mike has been an exceptional executive sponsor, both at Nike and now at Block, and his teams have been working really closely together with mine on evolving VPC Lattice. Thanks, Mike.
Thanks, Dave. Hey, everybody. Good to see you. Thanks for being here. Before we talk about our plans for Lattice, I want to tell you a little bit about our company. We've got multiple business units, and just to touch on a couple of them briefly, the first one was Square, and we used to be called Square. We were renamed Block at the beginning of last year. And the reason for the rename, or one of the reasons for the rename, was to create some room within that brand for the rest of these BUs. So each of these business units are their own vertical business. And if we talk about Square for a second, started off as the card reader that you could put onto an iPhone or an iPad, allow a bunch of businesses to do credit card processing that were not able to do it before. But we've expanded that into a point-of-sale system that you can use to run your coffee shop. Also a staffing solution, so the people that work at your pastry shop can get different shifts that they can see and then trade them between them. It also has a payroll feature, so you can pay your staff through Square Payroll. Invoices, so the more services that we see these businesses use, the stickier that they get with us, and more importantly, the more time we give back to them to focus on their business. If we think about Cash App started off as a Hack Week project within Square for how to do peer-to-peer payments, send money from one person to another person. And that's how most people first are introduced to the product. But it can also be a banking product for you. We have a savings product that allows you to set a savings plan, and also direct deposit, and all the different things that we think an individual would need with their relationship with money. Tidal is a music streaming service that also is a way that you can interact with those different artists, and particularly artists that are just getting their first start. Afterpay is a buy now, pay later company based in Australia that we acquired last year. That's got both a merchant side that allows businesses to offer buy now, pay later, and a consumer side for people that want to leverage that option when they're buying things. Spiral is an open source project where we are contributing back to the community. And TBD is a decentralized identity service that we are building that, among other things, can help with cross-border remittances, being able to securely and also with open protocols transparently send money to different people and across different identities. And so this slide right here is what we shared at our Investor Day last year, and it describes our business as an ecosystem of ecosystems. And what does that mean? Well, if you think about Square as offering those different services that we talked about, payments, payroll, staffing, invoices, that itself is a different ecosystem. If you think about Cash App as an ecosystem with that peer-to-peer payment service, with banking, with savings, with direct deposit, that itself is an ecosystem. Where we get even more power from these services is how we can connect them. And one example of that would be a Square seller that offers Afterpay as a buying option, and then you as a consumer using Cash App with that Afterpay payment option to complete that transaction. Another example, and this is one where we're seeing a lot of growth already that's really exciting, is a Square seller that uses Square Payroll to pay their staff, and their staff receives that money through Cash App direct deposit. And in that situation, those funds stay within our ecosystem, And it's not only easier for that Square seller in order to set up that direct deposit and payroll, it's easier for that staff. And so that ability for us to connect these ecosystems in this way is really the next phase of growth for our company. But if we look at the way that we are connected right now, it is a little inconsistent. It is secure, and as the CISO, I'm comfortable telling you it's secure, but there's also more cognitive load to secure it than we probably need. And the reason for that is twofold, really. One is these are different vertical businesses that have been growing by themselves, and so the stacks are a little bit different. In some of the technologies that we use, we're an API gateway shop. We also have a couple of different sidecar proxy technologies that we use, but also through acquisitions. And in some cases, when you're trying to do some of those ecosystem connections that we talked about, it doesn't feel like you're connecting within the same company. It feels like you're connecting to an external third-party company. Again, secure, but a little bit harder in terms of all the pieces that you need to keep track of cognitively, not only to secure, but for developers. It is too hard for our developers to think about how they can actualize that ecosystem connection with the setup that we have today, because you've got multiple different things you need to navigate in terms of connectivity and security between these different BUs. So enter Lattice, and why we're so excited about it. For one reason, we're an MTLS shop, so thank you, Dave and team, for supporting MTLS. The other side of it is, and what Dave talked about too, is the ability to integrate it gradually. So there's not a moment where we have to shift everything that we looked at on the previous slide into Lattice. We can take our time to do it. But the benefits that we're going to gain by doing that are, one, there's just less to think about in terms of the seams between these different business units, so it's easier to secure. And more importantly, it's a much more predictable development platform for all of our engineering teams that are building those connections between those ecosystems. And we've been tracking this product for many years. As Dave said, when I was at another place previously and first heard about what was then Project Mercury, the promise of it was incredibly exciting. Because we were at Nike, we had to build our own service-to-service auth mechanism. And while that is an important thing to do, it was tough and not that fun. And so that kind of undifferentiated heavy lifting, we would love to be able to have Lattice take care of for us. So it provides that predictability for developers. It provides that improved security for the way that we connect these ecosystems. So if we look at where we are next, we are completing our cloud migration. We've got about 7 more months before we'll finish moving all of our backend services out of our data centers onto AWS. Once we have all backend services on AWS, which we will have next summer, then we can start to adopt Lattice and have that consistent way that we can connect those services. We're also looking at ways that we can make it easier for developers to use Lattice to build these services on top, and doing a lot of education about the different ways that those service calls will be made and will be authenticated. And the other one is costs. If you think about that first slide, about that where we are today, lots of different connection points and technologies that we need to manage in terms of cost optimization. Getting to Lattice gets to the point where we have one way that we do it, we know it's consistent, and we know we can both secure it and manage it from a cost standpoint. So that's our plan. And I'd love to just turn it back to Dave.
Perfect.
Thank you.
Thanks, Mike. Excellent. So now you've heard from at least one other customer. There's plenty of other customers out there, too, that have been jumping onto the bandwagon. It's one of these things that's probably one of the most exciting updates to application networking in quite some time, if I do say so myself. It was very exciting to work on that project. VPC Lattice, though, is one of those areas where we just continue to innovate. And so after the launch in March, we've almost had a release almost every single month. And so it's one of these areas that we're trying to move very rapidly, because many of you have a bunch of different things that you need in order to move on to it. And so over this last year, we first started with talking to many of you that had applications fronted by ALB, or were on premises, or were in ECS. And so we added ALB as a target. When we talked to many of you as well, you wanted the ability to use Resource Access Manager in order to do things like create policies to say which IAM user could add a service to a particular service network. So we added customer managed permissions. Then we talked to you all about potential areas that you wanted to route across different networks. so we added shared VPC support. Next, there was this influx of really critical applications that needed this much higher level of security and compliance standards. And so we added a number of compliance standards, including things like SOC 2 and PCI and HIPAA. Many of these actually directly come from VPC itself because it is a VPC product. However, there's a subset that are slightly different. And then we moved to this area where many of you wanted the ability to add additional authentication on the targets itself. First, we focused on Lambda, making sure that we were adding things like which service network was it coming from, which VPC was it coming from, all those types of really critical data. So we did that for Lambda. And then we moved to EKS, and we added it to identity, the identity headers that are passed through. The interesting thing, and this feature was actually built partially because of feedback from Block, is that you all wanted the ability to chain things together. And so by having this identity actually pass through, you could actually go multi-region by actually taking this data, putting that identity, and passing it through as though it was another service. And so there's some very clever things that you can do with a number of these features. Perhaps the most interesting area has been around the EKS innovation and the work that we've done around it. And in particular, many of you are using VPC Lattice with EKS. At Preview and at GA, we launched an alpha version of our EKS controller. This is a native way for you to integrate VPC Lattice into EKS. And there's a lot of feedback that we've received over the last 9 months-ish. And we've taken that feedback, we've iterated on it, and we got it to a place where we were really excited about making sure we had feature parity, and we had addressed the major kind of milestones. So I'm excited to announce that the EKS controller for VPC Lattice is now in general availability. This, again, is an open source project, so it's one of those areas that you can actually contribute to if you'd like, and you can also contribute to the roadmap. And so the link up there on the screen directs you actually to that Git repo, so you can participate in the community. For those who already have, thank you. But again, this is one of those things for VPC Lattice where we really want to be actively engaged with the community, especially because there's very rich ecosystems around things like containers and Kubernetes and those different communities. And so really our goal is to engage with you all. So VPC Lattice, if you haven't checked it out, I would encourage you to do so. This is one of those things where, as a North Star, where I think together we're going over time. And really our goal here is to simplify it and take away that undifferentiated heavy lifting. The differences and simplifications in architectures has actually been exceptional. And some of the conversations I've had so far at this conference have really shown about how we can really take the networking designs and infrastructure to that next level and really simplify them. Now, we're actually finishing earlier, which means I've talked a little bit faster than I was expecting. But each of these areas we've talked about is actually an area we could spend a substantial amount of time. And in fact, we actually have deep dives into both VPC Lattice and the security and availability improvements we've been making to ELB. These are some of those sessions that cover them, and I would encourage you to check them out if you have a chance. Some of them are later today, and the rest of them are later this week. I know that you all have options on where to go and which presentations to go see, so I appreciate that you were here with us today. Mike, thanks so much for speaking as well. In terms of AWS, the way we operate is by taking your feedback and really evolving things. And so as an owner of application networking, I get to see all the different feedback from the previous reInvents, and we really work to kind of tailor the content as a part of what we do here. So I would encourage you to take the survey. You can go into your mobile app to do that. We left some time at the very end for you to do that. And then Mike and I will be in the back to take any questions that you may have. I don't see anyone from my team. They were supposed to be joining. Actually, they're just joining now. So I have some additional people that can answer questions if I don't know the answer. But thank you for the time, and thanks for joining us today.